This lesson's on capacitors. I'm not going to show you how to hook up every experiment here because you should be getting used to hooking up the circuits and understanding the basics of how they work. I do want to talk about the component, the capacitor. This is a 100 microfarad capacitor, so you need to look at the text on there and make sure you identify which capacitor you're using. Notice how there is a stripe, a white stripe on one side, and that stripe is going to help you identify the negative side of the capacitor, and that's going to always point towards the black wire on your battery strap, or you could say the negative on your battery. So it's important that this is hooked up the correct direction, and that if you're using two capacitors, whether in series or parallel, they're both hooked up going in the same direction. I want to talk through a little bit of these experiments here by just looking at the pictorial on your paper in your book. This is experiment 8, the slow light bulb. Just talk through how this works. Basically, power is going to come out of your battery. When you turn the switch on, it's going to go through a 3.3K resistor, and at that point it can go in two different directions, because as you remember, rows are hooked together. It can go through the 10K and light up the light bulb. So there's one circuit back to the negative, so we've got a big loop out here that's lighting up the light bulb when the switch is on, and at the same time, simultaneously, we're charging the capacitor. So there's a small loop right here. After the 3.3, it flows down that row. Notice that the long wire, or the positive side of the capacitor, is here connected with the resistor. Current travels through here, negative goes to the negative on the battery. So basically what's going to happen is when you turn the switch on, two things are going to be happening. You're going to be charging the capacitor, and secondly, you're going to be lighting up the light bulb. And if you've hooked up the capacitor correctly with a 100 microfarad capacitor, when you turn the switch off, this now will become a third circuit, and this will act as a battery, and this will release the electrons or the energy through this loop over here on the right, keeping the light bulb on a little bit longer. So instead of, in a normal circuit, the light bulb going on and off quickly, it'll go on and then it'll slowly go off as it drains the capacitor into the LED. This is experiment number 9. This is very similar to 8, with the exception of you have two capacitors hooked together in series. Remember, series means end to end. So current in this shorter loop here on the left will flow through one capacitor and then through the other capacitor. And what you're going to do is you're going to figure out what's happening with the values here. So we need to talk about how to calculate total capacitance of capacitors in series. So we're going to look at the math here on that. We're calculating series capacitors. And now, ironically, the formula for series capacitors is the exact opposite of that of series resistors. So if you had parallel resistors, we would have had R1 times R2 over R1 plus R2. Now we're using that same formula for series capacitors. So if you can remember series resistors and series resistors and parallel resistors, just flip-flop the formulas and it's going to be the same for capacitors. So here we're going to plug in C, so C1 times C2, or capacitor 1 times capacitor 2 over capacitor 1 plus capacitor 2. So this is the example you're not building, so that way you don't get the answer. But if we did hook up a 10 and a 10 in series, we would take 10 times 10 would be 100, over 10 plus 10 would be 20, and when you divided this out, you would get 5 microfarads. 5 microfarads is less than 10. So if you used one capacitor, you would have more capacitance than if you hooked up two of them in series. So you can see the total capacitance. So the practical side is, when you do this on that experiment 9, the bulb should go out more quickly than it did in 8. Experiment 10 is about parallel capacitors. So again, we have the makings of almost the exact same circuit here. Number 9 had series capacitors. Now we're hooking them up in parallel. Make sure the current can come into both capacitors in this row, and make sure they're exiting in the same row. And this is always the negative side. It may look like the bulb's coming on But if your capacitors aren't hooked up right, even though the bulb's on, you may not be doing the circuit correctly. So make sure the stripe is on this side or the short wire's on this side right here. But the formula for this is that of series resistors. So parallel capacitors is C1 plus C2. So for an example, if you had a 10 and a 10, you would just add them together, and you're going to end up getting 20 microfarads. So you're going to have a lot of capacitance, and so your bulb essentially is going to stay on the very longest when you hook up a 10 and a 100 together. You could even experiment, if you want to, with a 100 and a 100 and see how long you can keep that bulb on. Experiment 11 is called Make Your Own Battery. At first glance, this can look kind of confusing, but once it's explained to you, it's pretty easy. So here's your battery, and you got your red wire coming out of here. And what you're going to do is you're going to touch your red wire to this loose wire, and you're going to create a circuit. Now the switch isn't being used, even though it's shown here. So current's going to flow from here to here, go through the capacitor, charge it up. So even though there's no bulb in this circuit right here, you are charging up the capacitor. Okay, anytime there's a circuit, like a loop, okay, and this capacitor is hooked up in the correct direction with the negative side where it's shown, this will get charged up. Okay, then you disconnect this from the battery. Now we're not going to use the battery anymore. We're going to come over and we're going to make a loop right here. This will become our battery, this 100 microfarad capacitor. And when we touch this wire to this loose, unconnected resistor, current should flow to there, light up the light bulb, and this will be the negative. So we've actually created a little battery. So that's kind of a cool experiment. Create a loop here, charging up the capacitor, discharge the capacitor into the LED.